Welcome to Nick Does Mechanics. It's mechanics, it's definitely mechanics. Again, a very short, concise summary of a big blob of text here of a good old sliding or toppling question. What do we got? We have a laminar in a vertical plane. Everything does what it wants. Oh, line of action, vertical plane, bosh, 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 right? It's doing what we think. This laminar is an isosceles right-angled triangle. I've called the length there A. You can call it whatever you want. It doesn't really matter. So A, B, C. C directly above A. We're going to apply a force at C in the direction BC. So I should probably pop that in. What should we do? Should we do red? Let's do red. There we go. What should we call it? Let's call it F. I'm sure that will not come back to bite me in the bottom. The plane it is on is rough. And we are told it's going to slide before it topples. It will start sliding before it topples. So we're looking at the lower range of mu. But we need to find the range of values of mu, the coefficient of friction between my laminar and the surface that it is on. So let's add in some more forces. We have the weight. We'll have a reaction force. Now I'm going to pop the reaction force here, which will make sense in a second. Now we should also quite like a little bit of A geometry and B knowledge here. So first of all, we know that that is 45 degrees. That's going to be important for us in a sec. And blah, 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 blah. We also know that that distance there is A over 3. And we know that that distance there is A over 3. It's a good one to know that for triangles, your center of mass is a third of the way up the height on each side. Okay, so it's a third of the way up there, third of the way up there. So A over 3, A over 3. That is a great result to have in your back pocket when doing these things. Okay, we should have everything we need. So we're basically pushing it this way. And we're saying, well, it could patunk first, or it could sh first. And we need to figure that one out. Now, the reason I'm going to put R there is we're going to consider the case where it's just about to topple. And when it's just about to topple, the only point in contact really with the surface anymore is the point at A. So the reaction force is there. So let's have a look at toppling, shall we? Apart from the fact that it's a great fun word to say, toppling. Toppling, toppling, toppling. Anyway, it's got to the point where it's meaningless. Right. Let's take moments about A. So when it's just about to topple, the moments clockwise will be equal to the moments anti-clockwise. So I'm going to split my F into the bit that's actually not acting in the line of force. So that will be F cos 45. And the distance it will be is A. You could also, if you wanted, do its perpendicular distance there, which would be A cos 45. It doesn't matter. You end up with an A and a cos 45. And that is equal to W times A over 3. All right. Now, I won't lie to you. I very much feel like I want to cancel some stuff out. And if we rearrange that, ooh, right, too many colors. Back in the pouch. F would have to be root 2 over 3W. So that's my condition. And in fact, F would have to be bigger than or equal to that, but there we go. Right. Let's go for sliding. Now what's going to happen? Oh, do you know what we forgot? We forgot a force. We forgot friction. But of course, friction acts through A, same as the reaction force acts through A, so they do not have any turning effect, so it does not bother me for my toppling. Will bother me for my sliding, though. So let's have a look at our horizontal. What you doing there? Let's look at our horizontal forces. Forces going to the left will be F cos 45. Forces going to the right, friction. Now, if it is sliding, that has to be greater than or equal to 0. Now, looking at my forces vertically, I've got F sine 45. I know it's the same thing. Plus R has got to equal to W. And we also know that friction is mu r. Now let's start rearranging this. So friction is mu times r, which is W minus F sine 45, which is root 2 over 2. Let's not get silly about this. So let's pop that into there, which is F times root 2 over 2 minus mu W minus F root 2 over 2. And that's got to be positive. Well, we want to get F out of this. So we should get F times root 2 over 2 plus mu root 2 over 2 is equal to mu W, or greater than or equal to. So this tells me that F, if it's going to topple, as it's sliding, F is bigger than or equal to root 2, because root 2 over 2 is 1 over root 2, mu W over 1 plus mu. Okay. So two important things here. If it topples, that's my critical value. If it's sliding, that's my critical value. So if we know that it's going to slide before it topples, that tells me that, oh, do you know what? We can do that in red. Root 2 mu W over 1 plus mu, that critical value is less than that critical value. Now, what's quite nice here is that the W's cancel out. The root 2's cancel out, in fact. Three mu is less than or equal to 1 plus mu, which tells me that mu is less than or equal to a half. And of course, 0 at the bottom. In fact, we know it slides, so it can't actually be equal to a half. What's going to happen at a half? Chaos. Everything happens. It topples and slides at the same time. And can we actually get mu is equal to 0? Let's pretend we can. There is my answer. Voila. A good old bit of sliding before toppling with a little bit of geometry thrown in. And like I say, the real takeaway from this is know this result. The last thing you want to do when you are trying to solve one of these problems is sit down and figure out the center of mass of this bad boy from scratch. No one wants to do that. Okay, so it's a great one to have in your back pocket knowing that. How do you think of that? How do you think of that? How do you think of that? And even what do you think of that? Let us know. In the meantime, please subscribe, like the video, and hit the bell for notifications to know when we're going to go through this. We're going to be doing a bit of statistics coming up as well. So I am Nick, and I will see you then. Toodles.